So in this section, I want to talk about a historical storm surge in the North Sea. Okay? And maybe we don't have to go too much into detail. I just take the opportunity to introduce you to these charts used for tides. Okay, so tides are repeating, oscillating features. Okay, so they repeat on specific periods. Okay, in some regions the period can be 12 hours. In some regions they can be more 24 hours. And there are even periods which are slightly longer because they're created by the moon. You know, they're 12 hours and 25 minutes or so. Anyway, and you can actually show the features of these so-called tidal constituents in these maps. And there's two pieces of information shown in this map. There are these dashed lines, and the dashed lines show you the amplitude of the tide in centimeters. So let's have a look here. This is the North Sea. You can see that there's Norway here on the side. Let's activate the pointer. Yes, here. This is Norway. There's England here on the left, and then we have indeed France and Germany. Okay. All right. So what are these dashed lines? You can see that the amplitude of the tides increases towards the coast. Very similar to Kelvin. Okay. Tides are actually a form of Kelvin. Okay. They're a little bit different in a sense because they are triggered through resonance. You have the tidal forcing is there all the time. Whereas if your storm creates a storm surge, a Kelvin wave, a single it's just a once-off. Anyway, have a look at it. 180 centimeters, 1.8 meters, and amplitude is half the wave height. So in this area, you get almost a 4-meter sea level change, okay, on a regular basis. Okay, the high tide is 4 meters higher than the low tide. Okay. The other lines, the solid lines here are information on the phase, on the timing. And this is expressed here in 360 degrees. So from 0 to 360 is one full tidal cycle, and then the feature repeats. And you get information on the temporal evolution, the time evolution of the wave. And you have points where you actually never have any amplitude change, okay, where the amplitude is 0, and these points are called amphidromic points. So the waves travels around and essentially in an anti-clockwise sense, okay, anti-clockwise. So now an incoming Kelvin wave would behave exactly the same way. So imagine you have a big storm in the North Atlantic, creating a Kelvin wave moving through the North Sea, you know, in a way just with the highest amplitude along the coast and moving out on the eastern side. Okay, so now there are some observations of actually the biggest storm surge that we had in the North Sea, causing tremendous damage. Okay, and I want to show you the sea level at the locations which are hard to see here, but essentially at these blue stars. Can you see the blue star? And activate the laser. Here's one. There's one, and we do it in the sense of Kelvin wave propagation. We're in the northern hemisphere. The Kelvin wave would propagates along the coast with the coast on. Okay, so let's have a look at the reconstruction of the sea level. And what we see here are sea levels without tides, noting that this storm surge happened at the high tide. So where you already had the highest tide, and then the storm surge added sea level on top of it. Okay, and you can see now in the sense of Kelvin wave propagation, and the vertical initial disturbance was only 0.5 meter or so. Here, this is Aberdeen, and then we go to Leith and to Tees, Immingham, and you can see that the signal of the storm surge is one big wave, and it already has an amplitude of 1.5 meters. And then later on here, it's even something like 2 meters, a little bit more than 2 meters of an amplitude as it moves through. Okay, so this is an example of a big coastal Kelvin waves created through a storm as it travels through the North Sea and causing tremendous flooding in the Netherlands in particular. And this is the area that was flooded. And it's also the reason why they have a dike systems in the North Sea, which are fairly expensive to maintain. Again, this is in 1953. Fatalities, about 2,551 people killed. Okay, damages, many animals drowned, many buildings destroyed. Areas affected: Netherlands, Belgium, and England. Okay, and now you understand it. Now you understand which features can create storm surges. In the North Sea, the example can be extreme. In Australia, it's more the biggest storm surges that we had. Sort of maximum is a 2 meter storm surge as far as I remember. All right.